Hey guys, welcome back. Last part to this, we'll just be going over how to create these swept profiles. And what it is we're just taking a circle, sweeping it along a spline, a temporary spline that we're going to create, and then we're going to go jump to the next point, and then we create a new spline and do another sweep and go all the way around based on that spline length that we're going to get from the user. So I've just created a few variables here. And they're going to be open in the code here. So if we go look here, we have tail resolution, which is going to be how many points we're going to make along that tail for each tail. And then we're going to have a tail length. So how long is that tail going to be? So we go to our simplified image here. So in the last video, we put these arrowheads on each of these points. So now we're going to take these same distances where we're going to sample this spline and just run it back to this tail length we specify, and we're going to find points all along this spline, make those points into a new spline called temp spline, and then we're going to make that circle profile sweep from the start to the end. And I think that's about it for explanation. I'm just going to jump into it. So we're going to do a loop of loops actually. So we're going to loop over loop once to create each of these swept profiles, and we'll loop over each of these profiles to get points along this spline and make a new spline out of. So it's going to be a loop within a loop. So we're going to do a for loop. And we want to get spline points from earlier. So the number of splines we're going to make is going to be equal to that spline point number, just like we did for the arrowheads. And I've just made a new thing on this sequence here to plug into. First thing is going to be 0, that's fine. And what we're going to do is create that distance again for us to sample that spline at. So it's going to be very similar to before, where we're grabbing that distance between points new, multiplying that by t normalized, multiplying those, and then adding that to the index multiplied by the same distance, and that's just the distance from before that we were creating. Just redone again. I should have set that to a variable, but that's all right. So next thing we're going to do is clear the spline points from this temporary spline, and I've just made that already, but to add that, we just type in spline, add new spline, called mine temp spline, and we're just going to clear the points from here before we start. So just clear spline points, and we'll hook that up. And also I made this array and these two variables as well. So tail resolution, how many points we're going to make along the tail length, and then an array of all those spline points that we're going to create that sweep out of. So first thing I want to do is clear this array, make sure it's empty before we start making new points from it, and we're going to jump into our second for loop. All right, so first we want to create distances for each of these points. So if our resolution is 10, we want to get this distance, this distance, this distance, and so on until we have our 10 points. And we're going to add each of those points to that array. So first we're going to get just a number that goes from 0 to 1 along, and then we're going to get times that by the tail length to get a number that goes from 0 to the tail length, and then we get all those distances, and then we can then sample this spline from and create that new spline. So what I'm going to do is get the tail scale. Actually, I'm just going to use the tail length and not have a scale variable, and multiply this by -1. So we're going to go backwards along the curve to sample that point. So we're going to minus it by 1. And we're going to plug this into, so the next thing we want to do is find out how many times we're going to loop through this, which is going to be that point in tail curve. So tail resolution, get that, and subtracting by 1. plug that into here. So how many points we want to add to the array is going to be equal to that tile resolution. And then we're going to use this variable to first get that number from 0 to 1, so which is going to be index divided by this number here. So divide by this number here. So it's going from 0 to 0.1 to 0.2 to 0.3 to 0.4 all the way up to 1. So this is never going to be above 1. It's going to go from 0 to 1, and then we're going to times this by this number here to get us all the way back. So multiply and hook this up here. That looks good. And then we're going to add this to this number, which is going to be our time offset. So add those two together. And that looks good. I'm going to add this to a min function as well. Float min. So again, we want to cap these points at the spline length and 0. So when I'm in between 0 and the spline length, always we don't want to be sampling points that are past the spline length. So we'll go to spline length, spline length, spline length of this spline. And what this will do, if it's above the spline length, it's just going to cap it to the spline length. That's what this min function is doing. And we're going to do the same for a max of float and do max of 0. So anytime it's below 0, it's going to take the max of a negative number in 0, which is always going to be 0. So it can never be below 0. And we'll just sample that point along the spline. So set get transform at distance along spline. Use that distance, and that spline is going to be that same spline from before. Just drag that down. All right, and we want to do what we did before, although we're not going to split this structure out and make two rotators and get the tangent, because the tangent's not too important. We just want the spline point, which doesn't require a rotation value. So we're just going to make spline point. Input key is important. So for our first spline point, we want this at 0. The second one, we want it at 1, and we want to keep iterating over this to create kind of an index of spline points. So we're going to use this value here. Go into here, and we're going to add that to a temp tail and add array. And we're going to do that through the loop body, do it multiple times. I'm just going to check over that I have everything here. I think we're good. All right, so we can come out of this loop now. We've done everything in the loop we need to. So once it's completed, the next step is to spline add points. I'm just going to add points to this spline. So right now it's nothing, and we want to populate it with all those points that we've just added. So we will use this one and populate this spline with those points. So we have our tiny spline that goes just through here with these 10 points. Next, what we want to do is sample spline to transforms, and we'll take that same spline and we will sample this number of times. Sampling options. And we will change this to 10 samples, and we can make that a variable if we want to as well, to make it a higher resolution or a smaller resolution. And then we're going to use these frames. So these are the transforms that we've generated from the spline of these points. And then we can use that as our swept path. So what we'll do is append sweep polygon. Just a note, there is append sweep. There is append sweep polyline as well, but one, this won't cap the ends off, and two, it doesn't close the loop. I found as well. So if you plug a circle into the polyline vertices, it won't actually close that circle, and it won't create a fully enclosed mesh. So I didn't use that one. I used this one, so you can tick it as capped, and you'll still be able to change the start and end scale, so we can have it be a tip at the end. So this is our dynamic mesh component, which we always going to use as the same thing. So transform doesn't matter because we're going to plug in our path and our points, and that should be all we need. So temp tower spline points, plug that in, although we can't plug that in there. Polygon vertices, let me see. Oh, sorry, we already used that. We already used that here. We actually want this to be our 2D profile, which is going to be our circle. Create path 2D. 2D is fine. And our radius, we can make a variable. Otherwise, I'm just going to make this 50. And have another resolution for that circle as well. How many points in that circle? I'm just going to bump this up actually to 20, and then it's this poly path that we're going to plug into here, and it's going to convert that path to a bunch of points, which is nice. And I think we should be good to go now. I just compile that. All works well, and we'll give it a play. All right, something's gone wrong here. I'll just pause the video and figure that out. Okay, so there's a few things I forgot to do. First one is hooking up this position, so we can split this out and plug in the position, and just for safe measures we can plug in the rotation scale. The other thing as well I've got to do is set this tail resolution to about 10 and the length of the tail as well. Set that to 1000 as default, and I'll compile that and press play. And there we go, there's our arrows, and we'll just make sure this works by changing this. So change it to 500, become shorter. This one's not too important. To make sure this still works, so distance between, we can make 1500. That'll space them out more. And the speed, we can slow it down if we need to as well, which all seems to work. Awesome. So that's about it for our code. I'll just add one small thing, which is another Boolean, just to give us the option to make this tipped or not. So that's going to be a Boolean, and it's going to be this end scale. So the start scale is always going to be 1, but we might want this to end at 0 instead of 1, which is where we're going to base that off this Boolean. And what I found worked is a Boolean is either 0 or 1 anyway, so it works perfectly for plugging into here. I just found that we need to not this Boolean, so make it the opposite. Plug into end scale, it's going to convert it to an integer that when this is true, it's going to be a 0, and when this is false, it's going to be a 1. It's going to act like normal. And we'll set the default, compile that, set that to be unchecked by default, and play that. Actually, what we want to do is make this editable. Compile, and we go tipped and press play, and then all those arrows come to a point at the end. So that's about it for this tutorial. There is another kind of use case where this arrow could be here, and then when we make these spline points are all going to be bunched up here, and they're going to be capped to 0. So we're going to get a bunch of spline points here, which creates some glitchiness. But what we can do is, if the spline point isn't at an end, like it isn't of index 0 or the last index, and it's at 0 or the spline length, then we can choose to delete those spline points. So if we had all these bunched up here, we delete all these intermediate ones, and we keep this at 0, and this would be this one here, and we just have 2 spline points and create that curve like that. But it looks okay anyway. There is a little bit of artifacts at the end here, but not too worried about that. Looks okay to me. So that's it. Thanks everyone for watching, and stay tuned for the next one. Cheers.